So in this physics problem, we have a spring gun that's placed on a table, and it fires a ball horizontally outwards. And a student determines that the ball starts 1.5 meters above the floor and travels 3.2 meters horizontally before striking the floor. All right, so what we've got is we've got the ball, and it's fired out horizontally until it hits the ground. And the position of the ball, we can call it x, y, is governed by two different equations, the horizontal and the vertical component. Now the horizontal component is governed simply by the fact that, all right, let's just call this position right here 0, 1.5. This right here is 0, 0. And this point where it hits the ground is 3.2, 0. So for the horizontal, it starts with a position of 0 and then goes to 3.2. The thing is, we don't know with what velocity. And so what we'll say is v0 times time. And then for y, it starts with a height of 1.5, but then it loses it. And then it loses that according to minus 1/2 gravity, t squared. Now, the gravity constant, since we're in meters, is 9.8 meters per second squared. So that means our y equation is 1.5 minus 1/2 times 9.8 t squared. So that's going to be 1.5 minus 4.9 t squared. So we want to know the time that the ball is in the air. So essentially, how long does it take for it to hit the ground? So I want to solve for when y equals 0. So we substitute 0 in for y. And then we have 1.5 minus 4.9 t squared. I'll add the 4.9 to the other side. And that equals 1.5. And so then I'll take 1.5 and divide by 4.9. And so t squared equals 0.306. And then we take the square root of that. And technically this would produce two answers, a plus or a minus, but we're not dealing with negative time here. So 0.553 seconds. So that is how long the ball is in the air. So what we need to figure out is we need to figure out what is the initial velocity of the ball. Well, this is where this piece of information helps, because we know that at 0.553 the horizontal distance should be 3.2. So we take this piece of information, plug it in for t. We're going to take this piece of information and plug it in for x up here. So I take my equation, x equals v0 t, and plug in what I know, 3.2 for x, v0, and 0.553 in for time. So we'll divide 3.2 by 0.553, and so v0 equals 3.2 over 0.553. So v0 equals 5.78, round that to 4 meters per second. And I'm just going to assume seconds because they actually don't give us a time. So we'll just go with seconds to make this easy. Hope this helps.